Welcome to the Reading, Piping, and Instrumentation Diagrams by Jason Clements. The terminal objective for this training is the student will demonstrate an understanding of reading piping and instrumentation diagrams by passing an exam with 70% or better. Module 1, Anatomy of a PNID. The enabling learning objectives for this module are to identify the types of information that are found in the title block, identify and state the purpose of the general notes section, identify the information in the revision block and the symbols used to represent a change, describe how the grid system is used to locate an item. So here we have a PNID, a drawing that is used for representing a system to show the overall system and how it is operated, controlled. The PNID here is made up of the title block, the revision block, the notes block, the graphic drawing area, and the grid system. Let's take a look at the title block. The title block is broken down into 7 parts. The first is the title of the company. So here it's the Pueblo team. Under that would be the project name and the location of that project, which is a Pueblo Chemical Agent Destruction Pilot Plant that is located in Pueblo, Colorado. Next would be the contract number for that particular project. Then we have the title of the drawing itself. Now, the title gives you a snapshot of what you're looking at. It gives you an idea of what that particular drawing covers. Then we have scale. There are lots of scales out there used on different drawings. However, PNIDs do not use any scale. Therefore, you cannot tell the distance between items or the elevation of those items. Then we have the drawing number. The drawing number tells us what we're looking at. Gives us all kinds of information, what system that this particular drawing is part of, and what page we're on, basically. We'll talk about that in just a minute. The last block is the revisions block. This allows you to ensure that you have the most up-to-date revision by checking it against what has been published and what you have in your hand. So with the title block, let's take a look at the drawing number. Here we have a drawing number, and it is broken down into several parts. The first part of it is the project number. For PCAP, it is 24852. That is the number that represents our project versus any other project out there. The next block tells us what design stage we're at. For this project, we are now at the RD stage, or redesign stage. Then we have the document type. This block tells us what type of document we're looking at. And there are several different types of drawings out there. We, of course, are talking about PNIDs, so PNIDs are represented by M6. There are M2s, M4s, M5s, MJs, and M0s out there, but this particular class is going to focus on M6. Next, we have the system locator code. This block here tells us what system that the drawing is part of. Now, to get an understanding of what the systems are, you would have to look at your system locator codes to be able to distinguish between the different systems. Next, you have the design discipline. That is the letter that is part of the last block. The design discipline tells us what discipline the drawing falls under. Here we have an M, which represents mechanical. And the last part of this is the sequence number, or page number, drawing number itself. This distinguishes that you're on page 1 versus page 20. Above the title block, we have the revision block. A revision block tells us the revisions that have been made to that particular drawing. All drawings start with a revision number of 000. So by looking at the revision block, the very first column tells us our revision number. And the revision numbers work from the bottom up. Now there are only 5 spaces, so therefore if we go beyond revision 5, the older revisions will start falling off to make room. The next column is the date the revision occurred. And then we have the reason for revision. This is just going to be a small reason for revision that may not exactly be clear as to what the revision was. It could entail the documents that required a change, and those documents would have to be pulled up to and looked at to determine what the changes were required to create this drawing. And the last part of the revision block is the initials. The initials are there to show that this drawing has been checked and approved. So in these, there are 4 columns with initials. We have who did the drawing, the by, who checked it, the engineering group supervisor, and the project engineering manager. So here, if we were to have a revision 1, it would go above it and then continue up the line. Along with the revision block, we want to ensure that you know what changes were made on the drawing itself. So we do a couple things to draw your eye attention to the drawing area and where those changes were. So here we have a couple examples. I have a reducer here that is 1 inch by 3 inches, and if I was to suddenly decide that a change needed to be made and we wanted to put a valve in there, I would remove that reducer, place a valve in it, and I would put a cloud around it. The cloud represents that the area that changes were made in. Next to that cloud, I'm going to put a revision marker. That revision marker is a triangle, and in that revision marker, I'm going to put the revision number. Now, I'm only going to see the current revisions clouds. If I was to have more than just, if I was to have all revisions clouds, I'd have a very cloudy drawing, and then it would be very difficult to read. So here's an example of it, how it might look on a drawing. We've added a drain, therefore we put the cloud around it, and we have the revision marker with the revision number on it. Above the revision block is the notes block. The general notes block is just a block for engineers to communicate to the readers of the drawings some basic information that would not be clearly defined on the drawing itself. In this example, we're explaining the different agent contaminated category areas. But I could easily put references to other drawings, give more information about particular items on that drawing, and so on. Last of the anatomy of a P&ID is the grid system. We place a grid system around the drawing to help communicate to others where items are on the drawing. If I need someone to go deal with a piece of equipment, I want to give them the drawing number so they know what drawing to go to pull up, and if possible the grid coordinate for them to look at so they don't have to search the drawing. So if you look here, on the left and right of the drawing we have our letters. On the top and the bottom we have our numbers. By placing those together we can get a grid coordinate. The letter will always go first. So if I look left and right, I get my letter. If I look up and down, I get my number. Where they crisscross, that is my grid coordinate. So in this example, my grid coordinate would be B2. So to see this a little more, if I was to ask where my sun was, we would look left and right, and to get a C, top to bottom get a 3, and we would get C3. That concludes Module 1, Anatomy of a PNID. We've discussed the different parts of the PNID and how it's set up. We talked about the title block, the revisions block, the general notes block, the drawing area, and the grid that wraps the drawing. In our next module, we'll be talking about the lines and naming. So keep an eye out for Module 2 of Reading a Piping and Instrumentation Diagram.